Welcome back to another one of my mathematics tutorials. In this session, we will be looking at how to go about multiplying a matrix by another matrix. If you haven't seen my previous sessions explaining addition, subtraction, scalar multiplication of matrices, please be sure to do so. This session is actually a follow-up from those sessions. Now, let's consider a couple of matrices. Now, before explaining how to go about multiplying a matrix by another one, I need to determine the order of my matrices. So I'm going to list here the order of each of these matrices. Now, remember, the order tells us how many rows and how many columns each of our matrices has. So that first number tells us how many rows, and that second number tells us how many columns. Now, multiplication of two matrices is based on a row by column technique. To do this, we must make sure that the number of columns of our first matrix is equal to the number of rows of our second matrix. Now, let's see if we can multiply matrix A by matrix B. In order to do that, I need to examine the number of columns of matrix A as well as the number of rows of matrix B. And I am seeing that those two are actually equal. So A can be multiplied by B. What about A by C? I'm going to examine the number of columns of matrix A and the number of rows of matrix C. And I am seeing that they are both equal. So yes, matrix A can be multiplied by matrix C. What about matrix A by matrix D? Again, let's examine the number of columns of matrix A and the number of rows of matrix D. I am saying that they are not equal, so this cannot happen. Now, another thing to note is that when we are multiplying two matrices, other than writing down the order of our matrices and determining whether they can be multiplied, as in the case of A and B, we are seeing that they can be multiplied. These two numbers here, which tells us the number of rows and the number of columns here, this is going to tell us the order for our answer. So our answer here is going to be a 2 by 1 matrix. Let's look at matrix A and C. We are seeing that they can be multiplied. Matrix A is of order 2 by 2. Matrix C is of order 2 by 2. I have examined these two. Yes, they are the same, so they can be multiplied. And my answer will be a 2 by 2 matrix. Now, let us see how to multiply these matrices. So let's first multiply our matrix A by our matrix B. So we are seeing that our answer is going to be a 2 by 1 matrix. So it is going to take the same format as the matrix B, because B is a 2 by 1 matrix. Now, as I mentioned, in order to multiply matrices, it involves a row by column technique. So we are actually taking rows from our first matrix and multiplying them by columns of our second matrix. Now, if my answer is going to be a 2 by 1 matrix, it means that this element here is going to be in my first row, first column. And this element here is going to be in my second row, first column. Now, this information here is important because it is going to tell us what row needs to be multiplied by what column. So let's do that. Here I am seeing I must take my first row, which is this here, and multiply it by my first column, which is here. So I am going to get 2 multiplied by 2 and 3 multiplied by 0. So I'm going to write that here. It's going to be 2 by 2 and 3 by 0. And remember, it is only one element at the top here. So in order to get that one element, it needs to be combined using the operation of addition. Now, how did I determine that this 2 needs to be multiplied by this 2? Now, you can mentally visualize this row being turned and placed onto this column, and you will see that 2 will fit exactly onto this 2 and 3 will be placed onto this 0 here. So that is how I have determined what element needs to be multiplied by which one. Now I am seeing here my second row needs to be multiplied by my first column. So my second row by that first column, it's going to be 1, -1 by 2 and 4 by 0. So -1 by 2 and 4 by 0. And remember, we are combining it using addition. So we will get 2 by 2 is 4 plus 3 by 0 is 0. -1 by 2 is -2 plus 4 by 0 is 0. And we will get 4, -2. Let's try another one. Let's multiply A by C this time. So A by C is going to be 2, 3, -1, 4, multiplied by 3, 1, 5, 7. Remember, we already determined that they can be multiplied because we examined the number of columns of A and it was the same number as the number of rows of C. So yes, they can be multiplied and it will result in a 2 by 2 matrix. So it is actually going to look as if it is in the same format as A or C. So it's going to be a 2 by 2 matrix, which means that the element here is going to be in the first row, first column. Here, first row, second column. Here, second row, first column. And here, second row, second column. So now I will multiply my first row by my first column. First row, first column. So now it means that I will multiply 2 by 3 and 3 by 5. So here 2 by 3, add 3 by 5, and that's my first element. Next, I have to multiply first row by second column. So let me change my highlighter. I will now multiply first row, which is still this, by my second column, which is this one here. and I will get 2 by 1 and 3 by 7. 2 by 1 add 3 by 7. To get this element here, I need to multiply second row by first column. So second row by first column. So I will multiply -1 by 3 and 4 by 5. Lastly, I will multiply second row by second column. So it's going to be that second row by second column. So here now I will write -1 by 1 plus 4 by 7. And then we simply evaluate. And there you have it, 21, 23, 17, and 27. Something that is very important to note in multiplication is that the order in which matrices are multiplied is very important. A multiplied by C will not give you the same result as if you multiplied C by A. And therefore, it is said that multiplication of matrices is non-commutative. And what is meant by that? Simply, if we multiply A by C, we will not get the same result as if the order was interchanged and we multiplied C by A. So that is it there for multiplication of a matrix by a matrix. Don't forget to like, share, and subscribe for more of my videos.